Hi everyone. We're continuing working our way through the questions on Leetcode.com, and today we're going to focus on just having a look in case I missed any, or in case some stuff have jumped the list. Locked, big countries. There we go. Let's try that one. Wait, what? Nope. I do not wish to touch SQL in any way. I need Java problems. Okay, so big countries. Does it say that it's SQL? Anyway, construct binary search tree from Preorder Traversal. What? Give an array of integers preorder. Oh, it's the name of the array. Okay. Construct the tree and return its root. Okay, so I've read just one sentence. I'm going to look at the example. Preorder 851. So it goes depth first. Yeah. 1 and then 7. And then comes back, 10, 12. The output is 8, 5, 10, 1, 7, 0, 12. Okay, so it's binary, as in, I think there is a term for a tree that has to have, for every node, 2 children. And return the root. Okay, so we're building a tree which goes like breadth first kind of thing. It's 8, 5, 10 rather than 8, 5, 1. Okay, I have a mental model, I think, of what needs to happen. And the example is most of that. Okay, so we need to return the root. Oh, come on, let me do this. Yep. So we can construct using val. and then left and right nodes. So it goes like this. What I'm concerned about is that this is probably a simpler example than what could potentially happen. I'll try to meet the requirements of this example first, and then if it doesn't work, we're going to try and generalize the solution. My assumption is that the first element is going to be the root. Preorder 0. Yeah, I think we have to go for the general solution directly, I think, because from just looking at this, we don't know how this is constructed, yeah? So we have to check for this one. It's 5, so based on this, it has to go to the left. And then 1. And then 1 has to go to the left of 5. 7. What if we had 6 down the line somewhere? Would that have to go here? Because it's in between 5 and 6, 5 and 7. Or do we have to create the tree based on the order of the array that we are getting? Because otherwise I would have put 7 over here, right? Because that's the closest to 8, and it's between 5 and 8. But we actually use this one, so we encounter them and then we add them to the tree, possibly. Start at 1 because we already used 0. Value, preorder I. We need access to the current node somehow, right? So if value is less than root value, we do something. All the values of preorder are unique. Okay, that means we don't have to check for equality. So if this value that we got is less than the value of, not the root of the current one, then we have to go left. So we have to construct a new node with the value inside. This node goes to the left of the current one. And then do we switch the current one to the new that we created is the question. And then at some point, somehow, we need to backtrace to the node that we were dealing with. So 5 goes to the left, then we encounter 1. 1 goes to the left of 5, so that will work. Then we encounter 7. 7 doesn't go to the right of 1, it goes to the right of 5. So the output actually doesn't matter. I don't think we even need to do anything with the output, because we only return the tree node, the tree's root. So we just need to construct the tree correctly, and the formatting is not our concern. So it's just that and the image that matters. 7 goes to the right of 5. Then we encounter 10, which has to trace back to the original number. What I'm not sure about is, how do we know that 10 goes after 8? Because with what I've currently written so far, or at least what I'm going with this, 10 is going to be written after 7. Or is it that this branch only contains values that are less than 8? I think that's the key here, because then we don't need to check all the way. Yeah, I think that's the whole point of Well, that's kind of the whole point of binary trees anyway, right? So that we don't have to go back and check. We only need to check against the root node, which is why 10 could never be on the left-hand side of 8. It always has to be 10. So root node is quite important to have a reference to, not only just for returning, but also for comparison. So any number, any value rather, that is going to be compared to the root node, if it's less than root node, then it goes to the left branch. Else it goes to the right. And then within it, we have to do some further, almost like recursion. We do need to create a node for the value anyway, so let's do that here somewhere. And then do we go down that branch going top down, and then we check, suppose there is a 4 in here somewhere. 4 is to the left of 8. Then we go down here. 4 is to the left of 5. So it has to be this way. And it's to the right of 1. So 4 actually goes down here. So we have to keep track, and we can keep track because it forms a linked list, kind of, because that has a reference to the next one. And we have to check if it's left to the right or the right. Okay, so if value is less than root value, then we go and check if value is to the left of root left, and then left, and then left. So we need to find a way to reset a reference to the kind of the one that we're currently checking. And then the terminating condition would be something like if current checked, the one that we're currently checking, has, so if the value is less than the one that we're currently checking, and the value and the currently checking thing doesn't have the left node, in which case we're going to add the new node to that left. So current checked left is null, because by default it is not initialized to anything, so it's going to be null, which means current checked left is this node that we're currently whose value that we just created, and it's going to do the same for the right hand side. wonder if we can just use this current one, because I don't think we need that for anything else. In which case, can we use while? While value I don't know yet. But I think we can use this current, and then we can just reset. Something like if value is current, so current would be set to root, I think, here, because we need to do that for every number, every value. So this is the thing that will drive each new value. Current is set to root. Root is set to current, as in if value is less than current, then we have to replace the current with current left, and then keep checking. Let's do this only for the left branch, and then if that works, then we can do the same for the right branch. If value is less than current, then current is left, and then we have to keep doing that. That's my scratch pad. Yep. That makes sense. If current is null, because the left is null, then current, we can't do that. Okay. So I have to check current left before we do anything. Don't need that anymore. Else this thing happens. And this handles the right. This handles left side. This will handle only one level down, so we need to do this in a loop somewhere. Current left is null, then we know there's nothing to the current side, and we know that the value is less than that, so we have to add it to the left side. Else, because the left exists, we're setting the current to be that left one, so we have to check against that again, and we have to run this. So there needs to be something here that does this. Something like is added false, because if we've added the node to something, then we know we're done with that node, so we can continue. So while not is added, we're going to do this thing continuously. If we've added the node, then is added is true. We are happy. We can exit the loop and do the next thing now by resetting. Okay, this is making sense now. This is current, right. Is there anything else that's going to work? Well, this is not going to work. Let's try that one. That got accepted. Submit. Yay! That was a fun one, actually. And I'm not going to try and change it. I mean, it got accepted. 0 milliseconds. Can you do better than 0 milliseconds in general? I mean, negative time, that would be interesting. But I don't like that they kind of, 0 milliseconds is probably because they're measuring for really simple test cases. If you're running something 1,000,000 times, that would have got a better runtime comparison. Otherwise, that's mostly dependent on how the JVM performs at that specific moment in time. Because there's no way this is running at 0 milliseconds. I don't think, well, if we're being very pedantic, 0 milliseconds, you can't run anything in 0 milliseconds. That typically means nothing has run. But anyway, that is, I think, enough for today. I'm trying to keep these short, but sometimes they take longer for me to actually do them. So I'll see you everyone in the next one.